Okay, by now you should have Visual C# 2005 Express Edition installed on your computer, up and running. Perhaps you have a screen that looks similar to what you see now. I bet you're very excited and ready to start your first program. Well, generally in a programming class, the first program that you're going to do is some sort of simple Hello World application. And we're going to do that. But our idea of a Hello World application is going to be a bit more sophisticated than the standard Hello World apps that you generally see. We're going to really push the idea of this course. We're going to create a game. Now, we're not expecting you to truly understand every single thing we're doing. The concepts, that is what is important. As a matter of fact, in this video here, we're going to spend all of our time simply talking about what it is we're going to do. So, Logan, let's go ahead and bring up Photoshop. So I have a whiteboard. All right, and now let's bring up the game that they're going to create. Yeah, Logan's like the man behind the curtain right now. You can't hear him. Well, actually, you can in about 2 seconds. All right, here it is. It is a simple text-based game. The Hyperion Project. It's an XNA Xtreme 101 game by 3D Buzz. We're going to show you guys how you can put this together in a way that you're going to have an engine and the ability to create many text-based adventure games utilizing this engine. And we're going to talk about everything involved in creating it, and we're going to actually code every bit of it. Then we're going to shift gears and we're going to talk about the level design part now that an engine is in place, and we're going to talk about everything that's required to get some good gameplay so that your player of the game is kind of kept on their toes and has a good time, because in the end that's what games are all about. So here you go. We get basically a little introduction to our game. You are a private detective in the year 2078, blah, 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 blah. A bunch of really interesting stuff. At the bottom, note, you may type help at any time to see a list of commands. Now, press any key to begin. Well, Logan, let's press a key to begin. All right, the Troy Tech main entrance hall is mostly darkened. Only emergency lighting illuminates the walls from beneath. And it goes on and on, right? So we have a description of the room. Up underneath the description, we have items in the room. We have passkey 1, and we have possible directions. So the engine that we're going to create for our Hello World app needs to be able to support a virtual world. Of course, this is all going to be delivered through text, but in the end, it is indeed a virtual world. So we're in this virtual world. We need to be able to do a few things. One, travel from one location to another. And second, we need to be able to pick things up and put things down. And we see both of these things present themselves right away on this very first screen, with at the bottom, items in room. Well, there's an item in the room, and possible directions that we can go. So just to give you a quick taste of how this works, we're in this room. We can go east and west. Let's take a look at what is to the east. So let's move to the east.
I could use the move command.
So using the move command, he types in east and hits enter. And now this room is where all employees and visitors are scanned before entering the facility. It looks like someone, and it blah, blah, blah. It goes on and on, right? Look at this up underneath. Items in the room. Security guard PDA. And we have possible directions. We can move back west. So basically, where we just came from is the only way we can go back to. So in this room, there is something on the floor. Let's pick it up. Now, that's a lot of stuff to type, yeah, Logan. No. Sorry about that. So Logan is going to pick up this security guard PDA. It is not case sensitive, so he can type it uppercase, lowercase, doesn't matter. The PDA has one message on it. And it goes on, and this is little clues for what's going on in the game to give you an idea of what you need to do in order to solve this game. So he's picked the PDA up. Now, what shall I do? Well, let's first type the command help. Remember, at the very beginning, it said that you can type help to get a list of commands. Well, available commands. We can, of course, type help. We can type exit. We can move, as you guys just saw Logan do. We can look, pick up items, drop items, inventory, and even check where you are. So let's go ahead and type look. And what that's going to do is give us another description of that room, as if we had just walked into it. And here it is again. This room is where all employees and visitors are scanned before entering the facility. Blah, blah, blah. Take a look at this. Items in room. None. Possible directions. West. So we have picked that item up. That means we must have that item on our person somewhere. We saw a second ago when Logan typed the help command that one of the commands was inventory. Let's go ahead and type inventory. All right, so inventory. Your inventory contains security guard PDA, weight 1. We're not going to say that's 1 pound. It's one
weight unit.
Yeah, it's 1 weight unit in the future, because later on you guys are going to pick up like pieces of paper and they're going to weigh 1 too, and you're going to think, why does paper weigh a pound? It's not. But here's what's interesting here. Total weight, 1 out of 6. What shall I do? The cool thing about this is we're also going to show you guys how you can make your game engine just a bit more sophisticated by making your objects have weight, and then the player is going to have to really kind of juggle objects around, because he's not going to be able to walk from room to room to room and pick up every single thing, because what will happen is he'll reach this 6 weight units, and when he does, the next item he tries to pick up is going to put him over that, and it's not going to allow him to do that. So Logan, let's go ahead and move back to the west real quick.
And as a matter of fact, I'm going to look first, because
Okay.
let's say we didn't remember there was an exit to the west, so we'll look around and say, okay, there's our exit to the west. So move west.
Okay, so now here we are, the Troy Tech main entrance hall, so we're back there. And sometimes you might just want to get a quick, where am I, right? So you guys saw that that is indeed a command, so where am I? We're in the main entrance hall. So let's go ahead and do a look again. Now in this room we've got a passkey. Let's go ahead and pick that passkey 1 up. Okay, these magnetic keys work off your body's own magnetic field. Just having the key in your possession will open all doors coded to the same security level. What shall I do? Well, let's check our inventory to make sure we now have 2 items in the inventory and that our weight is changing. Check it out. Security guard PDA, weight 1. Passkey 1, weight 1 unit. Boy, they're heavy. Total weight, 2 out of 6. What shall I do? Let's go ahead and look again. And from here, well, we've already been, what, to the east? So let's go to the west.
Move west.
And now the visitors lounge. Looks strangely, and then it goes on and on with its description of the visitors lounge. There's an item in this room. It's a, what is that, a Tri-D phone. Zach is our level designer, and you guys will be hearing from him shortly. But it's our Tri-D phone, and possible directions. Well, we can go back east. So it looks like at this point, that's all the directions we can go, doesn't it?
It would seem that way.
It would seem that way. So something needs to happen, and at this point you really need to start reading the descriptions and figuring out what needs to be placed where in order to make other doors unlock. Now, I wanted to give you this very quick run through of just, this is only a teeny piece of the game. One of the 3D Buzz employees here, Terry Wilson, who's a really big gamer, spent over 5 hours going through this game to finally reach its ending. And out of that 5 hours, he died, I believe it was twice, and then, of course, finally made it to the ending after realizing exactly what clues were important enough to get him there. So it's a very diverse game in regards to possibilities, because there's not just one death, there's numerous deaths. There's not just one way to win. There's actually 4 different ways to win this game. So there's a lot going on. And what I'd like for you guys to walk away with by the time we get to the end of all of the lessons about our Hellow World app that we're creating here is just kind of a general overview of how game design happens. And we're, of course, picking on a text-based game because it's going to be one of our most simplistic approaches to demonstrate this. And I want you to also walk away from the lessons with a very basic understanding of what an object is, because C# is an object-oriented language from ground up. Everything that exists in C# is an object.
And it's not just that object orientation is a feature in C#, it is a very core fundamental idea you have to understand. Everything in C# is object-oriented, so it is just one of the basics you have to know in order to move around and work within the world of C#.
Exactly. So, now that you've seen the game, and you know what I'm looking for, and you know by the time we get to the end, you're not going to understand every single thing, but that's okay. That is what you have to remember. You don't have to understand it all. I do want you to follow through all of the introductory videos that take you through creating this Hyperion Project game. It will have a significant value to you. I promise you that. Even if, again, you don't walk away understanding, let's say you don't understand 3/4 of it, it's still going to mean a lot. Because after we're done with the Hyperion Project game, we're then going to start backing up and breaking things down at a much lower level, but you will have spent so much time with the Hyperion Project going through coding it yourself. Hopefully you guys will indeed, well, code it yourself and follow along with us, you'll have done it so much that all of a sudden you're going to say, hey, I knew that. Oh, that makes sense. Oh, yeah, I've known that now for a while. That's no longer basic stuff. That's just obvious stuff. So that's kind of the goal. But we are going to back up and start explaining the fundamental language of C# after this game here is complete. But this gives you guys a really spectacular overview of game design.
Think of yourself as being apprenticed at a game design house, and right now your job is to watch some people make a game.
You got it. Now, let's go ahead and minimize our game, Logan. Ladies and gentlemen, please bear with me with my incredibly horrible whiteboard skills because I'm not really great with writing with this stuff. So I'll do the best I can. So the first thing I want us to understand is objects. We deal with objects on a daily basis, don't we, Logan?
Well, in the world we live in, everything is separated into discrete objects. You're different from the glass you drank out of this morning. You're different than the car you might have ridden in. There's separate discrete objects.
But every single one of those things is indeed an object. The grass outside, the blades of grass, they're objects. The sun in the sky is an object. Our house is an object, which is, well, comprised of all sorts of objects. We've got walls, we've got doors, we have light fixtures, we have light switches, we have receptacles. The list goes on and on. Logan's an object. I'm an object. We're two very similar objects. We're both, well, from the human class, and we're both from the male class. And we both have the ability to walk and talk, but Logan has different properties than I do. He has a different height, he has a different weight, his whole look is different, and he has a different strength than I do. He can run a heck of a lot faster than I can. So there's definitely things in there that make us different from one another. The neat thing about working in an object-oriented language, or better yet, let me rephrase that. The neat thing about working in C# is that, as Logan said a second ago, from ground up, everything is an object. So, I mean, the moment you go in there, if you've ever coded before in, let's say, C, and you start working in main, you don't have, or even C++, the C++ state, you start working in your main function, right, for the program, you don't have an object. Here, guess what? You're in an object. Everything is an object. Well, for those of you that have never coded before, you're probably thinking, what is he talking about? Well, let me, before we start getting into it in a code point of view, because remember, this is a very general overview, let's talk about it in a little more depth from a real-world object point of view. Sound good?
Yeah, sounds good.
So what I'm going to pick on is something that's common to almost everybody. Almost everybody has a TV. Almost everybody has a DVD player. And nowadays, everybody, even if you don't have a TV and a DVD player, has a remote control. So those are going to be the objects that we're going to pick on. So let me come in here. And here is an object. And this object is a universal remote control. Okay? Now, we're going to have some TVs. Most people nowadays have more than one TV in their house. So we're going to say that we've got TV number 1. We've got TV number 2. And we also have our DVD player. Now, I don't think anybody is going to argue with me, Logan, that these are not actual objects. And these are all objects that have properties. I mean, think about it. Our TV has a size, it has a weight, it has a color. I've got a silver one in one room and I have a black one in another room. The universal remote. Come on, guys, you know they have properties. They have different sizes. They come in different shapes. They come in different colors. Man, have you seen all the different colors of remotes available these days? Everything from clear transparent to like neon blue. It's all been done, I promise you. DVD players, again, they all have their own set of properties and all. But it goes even further than that. So not only do they have their properties, and these objects also have the ability to interact, because of course with a remote control, we can talk to these objects. Wow, object interaction. And not only that, but we can send information from the DVD player to the TV. And on some more modern setups, you can also do neat stuff like this, where the TV might be sending information over to the DVD player. So here is a setup of a series of objects, and these objects we know are all different, but it does allow me to demonstrate something quickly that you guys are going to see real fast in the Hyperion Project, and that is, when creating objects, sometimes we're going to be dealing with an object that we're going to have many of. An example would be an item in our game. How boring would the game be if you only had one item? You truck your way through 15 different rooms and you pick up the gold key and you win. That's not very exciting from a game design point of view or from a player's point of view. But if you had multiple items and you had to pick up multiple items and rearrange them in the level and all, now things can become a little bit tricky. So you're going to have some cases where you'll have multiple items of the same type, and you'll have times where you're going to have only a single object. And in this case, I've kind of drawn it that way. Now let's pretend that this is it in the whole world. We don't have any other remote controls, no other DVD players, but we have the ability to have multiple TVs. So right here, this would be a fantastic example of a static object. That's a static object. That's a static object. I am just dropping words, ladies and gentlemen. That is all. Just put that in your mind. Static means there's only one. An example, in the game that we're going to design, it is not a multiplayer game. How many players do you think are going to be running around in the level? One. So he's going to be a static object. There's only one player. Okay, so keep that in mind. He's running around in the level. Well, how many levels are we going to have? Well, we're making a very simple game. This simple game will contain one level that you're running around in. So one, the level will be static. Now, when running around in the level, what are you really running around in? You're running around in rooms. We need more than one room. That'd be pretty boring. Welcome to the entrance hall. Well, where can I go? Well, nowhere. We only have one entrance hall. We only have one room. Well, again, we have a boring game. So, at that, we have to have multiple rooms, so the rooms will not be static. Now, the TV down here, it, on the other hand, it kind of, if you think about it, that's like our rooms or our items. Because couldn't I go out and I could buy another TV, then suddenly we have TV object number 3 in the room? And so you kind of get the idea, Logan. Does that make sense?
Because your remote is a universal remote, you could use your same remote on the new TV.
That's right.
You could buy 100 TVs, and you could run TV to TV and turn them all on with the one remote.
Exactly. So out of that little discussion, the only thing I hope I did is I just dropped this word static in your mind, and when you think static, you're going to think just one of. Now, later on, static's going to have a much stronger implication when we get into more advanced object-oriented design. Right now, though, we're just talking about a single object, as opposed to the ability to create multiple objects from a blueprint. In this particular case, you could think that somewhere, let's say that these are Sony Trinitron TVs, all right? So somewhere exists a blueprint. So here's our little blueprint. This blueprint is called a class. So I'm dropping words, right? Just that's all. You don't have to remember them right now, but you'll see them again a million times. This class is a blueprint on how an object can be created, and from this class we can derive this TV, and we can derive this TV, and as Logan says, we can derive 100 more TVs. But we can make them all different, because one TV might be a 65-inch widescreen, another TV might be some 13-inch thing that you're going to throw in your shower or something, I don't know. But you can have these, different kinds of TVs, but they're all derived from the same basic blueprints, just with the ability to start changing things around. No different than, a house. If you go out and you're going to build a home and you go and look through a whole bunch of different blueprints, you can find the blueprints for the home you want. But now this is what's real interesting. You take those blueprints to a contractor, you can say, this is the home I want. Now, for the fixtures in the house for plumbing, I want brand Delta, and that is a real brand. That's a very good brand.
Even simpler property would be that I want the walls to be painted blue.
And I want the walls blue.
And the blueprint might not actually even give a suggestion for the color of the walls. It's just assumed that you will choose a wall color property in your house.
Perhaps my floor, I want it to be brick as opposed to tile. And in here, I want it hardwood as opposed to carpet. So all of these properties that can be changed in your blueprint. But in the end, what do you have? You have a home that's built to that specification. So, very general class discussion. That's all I'm trying to do right now. So, with this, let's introduce you guys to a couple more keywords I want to drop. So far we've dropped the word static. We've dropped the word class. Now, let's drop the word methods. Oh, that sounds interesting. Well, let's see. TV. So, I'll just do it generally. TV methods. Now, in this simple case, both TV1 and TV2 are going to have the same methods. They were, of course, derived from the class of the generic TV, or the general TV, that we're going to build from. And they have such methods as, and I've already mentioned this when I was talking about the comparison between Logan and I, things like turn on. Remember I said Logan and I can walk, we can run, we can eat. We can turn off. How about change channel? I want you guys to look for, I mean, right now you're going, yeah, duh. Those are just, things you can do with the TV, but really be thinking, what kind of things are you doing? I can change the volume. Let's keep it real short. I'll just call it volume, but change volume would be a little bit more, accurate. So just pretend the word changes in front of it. Now the DVD player has also got methods. So DVD methods. Hopefully you guys have been thinking as I'm writing here, what kind of methods would the DVD player have? Well, it's just play would be one. Stop. Pause. It would also have a turn on, turn off. Hopefully, well, let's do one more. Let's put in the remote. I'll shorten this up instead of typing out or writing out universal, just remote methods. And the remote methods are really simple. Check this out. How about it just has press button. Look very carefully at all these guys. They have something in common. All of these names. They describe an action, like a verb. When naming your methods, when you start getting into the world of programming, it's a good idea to just think of all methods, it's an action. So it's like a verb. So use a verb for the naming. That's what we're going to do here. So in this case right here, turn on TV, turn off TV, TV to change the channel. Oh yeah, I called it channel. There we go. Change the volume. Pretend that's there. Play, stop, pause, press button. All verbs. So methods. Just for right now, starting this whole game out, we're going to say methods equal verbs. Now, right now, guys, don't start thinking programming. Don't make this a confusing thing if you're new to the world of programming. Just lock these very generic words I'm tossing around into your head. You think of methods, it's an action, some sort of action that's happening. Now, we have properties, and we've discussed that too. A second ago, we said that the TV, one's a 65-inch, one's a 13-inch. So we have TV properties. So the next keyword I'm dropping here is properties. So what kind of TV properties would our TVs have? Well, check this out. Here's one you may not have seen coming. Location. Ooh. Let's see. TV1's dot location is in the living room. TV2's dot location is in the bedroom. So we have just provided that property with some information, where they're at, the location. Now, of course, the things you guys probably were thinking, as I said a second ago, would be screen size. Let's see, we could have channel. It's a good property. And I'll go ahead and write volume down here. And let me do this. I'm not going to feel good unless I do this. There you go. Change volume, just so I don't see volume. So volume. All right, well, there we go. What about DVD type properties? What do we have over here for DVD properties? Well, DVD could have a location. Where is it sitting right now? It could have, here's one, a disc type. Because internally we're going to do different things when we start playing depending on if it is a DVD that's in there or a CD that is in there. All right, very cool. Let's see, what other kind of properties could it have? How about a speed? I don't know about you guys, but I've got two DVD players, and they both allow me to do things like play back at normal speed, or let me do, a quarter speed, or maybe 1/2 speed. So, I can control the speed as playing back. These are properties. Make sense, Logan? Anything you want to add to all this?
Right. That pretty much covers it. That's the idea, though, is that these properties they're just a setting that is currently set for that. It's something that we can see. We can look at a TV or a DVD player, and like, for example, the disc type isn't something we can necessarily set, but it is something we can look at the DVD player and see what kind of disc is in it. It will usually show a CD player or a movie player, depending on that.
Right.
But it'll usually come up with an icon that shows DVD or CD, and that's one of its visual screen-based properties.
Yeah.
Whereas location is you can just look into the room and say, okay, it's on the third shelf, and that's the DVD player's location.
Right. So looking at this, you guys kind of starting to pick up a little relationship in regards to properties. Now, this isn't the rule up here. This is just kind of a guideline. Properties are kind of, oh, that is properties. There we go. Kind of like nouns. Agreed, Logan?
Right, and that's how you would refer to them. You just ask it what its location is.
Right. What is its current channel? What disk type does it have in it? Etc. So just a quick way of looking at methods. They're like actions. They're verbs, properties, nouns. Very simple, very generic right now. That's all I'm wanting to get across to everybody. So keywords that I've dropped. Let's just start over here. We've got class. Well, you don't have to know how to use it in programming right now. You will. Class is just a blueprint, kind of a template on how we're going to derive an object from it. So we've got a class. Let's pretend in our house we have a small TV factory out back, and we can pump TVs out to make this whole picture work properly. So we have the ability to create multiple TVs.
Or another thing to look at is in your kitchen you might have a recipe.
Ooh.
That you don't have any food made from that recipe yet, but if you look at the recipe and follow it, you can come up with food and produce food using that recipe.
And my blender in there, I only have one blender, so it's static. I can't produce another blender.
The recipe could call for using the blender with the apple to make
more
apple
food.
Juice or something.
Exactly. So static, ladies and gentlemen, when you see us using static, what are you going to think at the moment? Just one of. So again, a player running around in our game, it's not a multiplayer game. How many players do we have? One. So what kind of class or what kind of object would it be? It'd be a static object, a static class. Okay? So I think this kind of, and then the other keywords, just really quickly before I tear myself away. Methods. Okay? Verbs, actions, right? Things we're going to do. It's going to turn on. It's going to turn off. It's going to stop. Properties. All right? Well, properties, location, screen size, etc. So there you go. I think, Logan, we've done a pretty good job at just dropping a few things that they're going to become intimately familiar with as we work our way through our very, very first program. You think?
Yeah, it's just the almost physical fundamentals of how things are divided up. There is different discrete objects, and those are what we're looking at here, what objects are, what they can do, and what properties they have.
All right, so let's find my little mouse guy right here, and let's come over here. Let's add a new layer, and let's see. I'm not letting you guys out of the party quite so fast, so if we come over here, do that real fast. Let's go back up here and grab this, and yeah, we're ready to start doing some more drawing. So now that you guys have, seen a little bit about objects, and we talked a little bit about methods and properties, let's talk about our game. Now we're going to slowly start sliding over to the world of programming, but before we touch a single piece of code, we better know what it is we want to make. Do you guys hear me? For those of you that are beginners, that is the most important thing I can tell you throughout this entire course. Know what it is you're going to make before you try to make it. There's nothing worse than sitting down at a computer and you're new to programming and you're going to start dabbling and you got an idea. Your idea will change 50 times over the course of 2 days. Am I right, Logan?
Oh, yeah, if not for 5 minutes.
No kidding. And what is that going to do? That's going to breed frustration.
Even worse is what will happen is you won't realize that your ideas are changing. If you just sit down and start coding, your mindset will change based on what you're looking at. So your game will change without you even realizing it.
Exactly. So what is important here? It is to, well, let's go down here and make sure we can write with a color you can see. Plan your game. Every single game we do in the C#/XNA Xtreme 101 class, we will have a plan. So let's start out with a very basic plan here for the Hyperion Project. The first thing I know, Logan, that I want the ability to do is I want the ability to easily create 100 different text-based adventures from this game. So that means it has to be designed in a very particular way. I also know that I don't want to have to design all those games because I'm not the world's most talented game designer out there.
Or story writer or artist.
Story writer, exactly. So I want other people to design games. I don't want other people to have to come in here and code every single thing every time. So the old days of hard coding every single thing in, that's out. We're not going to do that. We need to generate, well, what's known as an engine. And I think everybody that's listening to us, most everybody, has probably heard the term engine. Just, well, for the simple fact, you hear, here comes a new game by Company X based on the Unreal Engine. Here comes another new game based off the Half-Life 2, the Source Engine, or the Doom 3 engine. So this term engine, well, what is an engine? An engine gives all of the raw requirements needed to have that kind of a game in place. Or, well, I don't even want to say that kind, because you can actually deviate quite a bit by manipulating the data within the engine to come up with different types. But basically, it is an infrastructure that is in place that a level designer can then turn around and create assets and all that can then be read in by the engine, and da-da, you have a game. So I want to do the same thing here. I want to keep this really simple. So we're going to kind of break this up into multiple stages. The first one, I want engine design. I want this base platform engine that doesn't house a game, that's able to process a bunch of information. And it takes our level designer and separates him from us. And it also gives him the ability to easily create multiple games utilizing our engine.
Right. It's like the engine gives the level designer a feature set.
Yep.
It gives the level designer the ability to make a room, to make a lot of rooms, and the ability to place things in those rooms.
Well, here's a good example of an engine. My computer. We have a computer. It has the ability to do all of this stuff. Now, how I use it and the output I produce from it, oh, that's up to me, the user.
Right. The idea is that the engine is a generalized and, in some cases, I won't say simple, but the idea is it has a set number of things it can do. Like, your computer can't draw a picture of a cat, for example.
But I can sit
or an
down
artist can sit down
and use my computer and produce a picture of a cat.
But the computer by itself will never just generate a picture of a cat. We can't turn it on and see a cat get printed out.
I can. No, I'm just kidding.
You have a really cool computer.
Well, I have the new upgraded BIOS in it. It's called the Cat BIOS. All right, so from here, the next thing I want us to do is I want us to have the engine set up in such a way that I can bring in an artist or a level designer. This is where people get really confused with game design. We're building a base engine, but you don't have a game. This is not your game back here, ladies and gentlemen. Without it, we cannot facilitate a game. But this is not your game. Using our engine, right, the level designer can then put together a game that is then output into our, you could say, final, let me write that a little bit better, final game. Which is exactly what has happened with the Hyperion Project. Logan put together an engine. Zach came in, sat down, and designed all of the descriptions of the rooms and how the rooms flowed with one another, what objects would appear, and also what base rules applied to the game for winning and dying. All of that was then merged together to give you guys a final game. But here's the beauty behind it. With the engine in place, I can now come over here and turn around to Terry and teach him what he needs to, the format basically, that our engine is looking for to design a level. So here we come with another level designer, right? And this level designer, being Terry, can then utilize our engine and guess what? Produce a completely different game. That's a game, okay? Just trust me on it. And you see how we can just kind of keep repeating this process here, utilizing the same engine. Again, ladies and gentlemen, this is something that you have seen happening now for years. The Doom 1 engine was used for other games. We had the Quake engine, the Quake 3 engine. I mean, we've got, so many engines, the Unreal engine.
Right. Another way to visualize or to think about an engine is it's simply a cause and effect simulator.
Mm-hmm.
It's to give a practical example, I once made a very simple program that drew a dot on the screen. and I had the arrow keys move that dot 1 unit in the direction you press the key. That by itself wasn't really a game. It was an engine.
Right.
It was the dot moving engine.
Right.
That engine became a game after I laid in some rules and said that if the dot hit the edge of the screen, it died. And if the dot hit the center of the screen, you won, or something very simple. But again, it's those game rules that turned the engine into a game.
Right.
That engine could then be turned around, and with more advanced rules, could become a recognized game like Pac-Man. But again, the idea is that the engine is just a simple cause and effect simulator. It allows you to make input happen visually or by text. But again, it's take some known metrics, input, and then display some known results like text or graphics.
And now you have a game player or a gamer that is interacting, inputting and receiving output and getting an entertainment from it. Okay.
It's almost like the layer that lets the player interact with the level designer's story.
Right. So there you go. Now that we have a plan, this is our very raw plan. I mean, super raw. I just know I want Logan and I to design an engine, and I want Zach to come in and use our engine to make the game. I don't know what the final, and that is the truth. With the Hyperion Project, I did not know what the final game was going to be. I gave him the engine, said this is how it works. He went home. Next morning, he said, here you go, give it a shot. And I was like, Terry, here you go, give it a try. And 5 hours later, Terry was, man, that was hard. But it all came together.
For me personally, I probably haven't seen more than 5 rooms within the game.
That's very true.
I put the engine together, and I've done some testing on it.
Precisely.
But I haven't actually played the game myself. I just made the engine. The level design was handed off to Zach.
So now that we have the start of the plan, very, very rough stuff in place, what I want to do, let's come in here. Hope you guys don't mind. You guys can always fast forward stuff you don't like. Let's just come over here, flip our colors, grab our paintbrush, drop down a little bit of white, come back over here, flip that back around, and hide this for the moment. Let's do some more talking. All right, let's talk about the objects, because we know that our game, we need the ability to walk around the world. Let's talk a little bit about the game itself. So let's just say rough overview.
Or what engine features we need in this game.
Yeah, and that's going to be derived from our rough overview.
Exactly.
We know that we're going to have some sort of grid-based level. We know that it's only going to be a single player, so we'll have a player. We know that the player can interact at a very low level, pick up and drop, with items. So there needs to be items. We know that with the grid-based level, we're going to be dealing with rooms. And these rooms, we're going to have to do things like give us descriptions. So we can walk around. So here we are over here. And we could have a very simple 3x3 level. And we could be, let's say we start right here. So this is our player. And then our player could receive a description for this room. Our player could then walk over here and walk over here and be in this room if it was allowed in the way the level was put together. There might be an item X on the ground. The player can take item X, pick it up, and put it in their pocket. So that's the basic gist of it. And we know that there's got to be some rules in place, because if there's no rules in place, well, then the game could never be won. There's no point. And so the rules are like, how do you win? How do you die? So with the rules, we'll just put win, die. Die. There we go. Win, die. So this is the kind of general idea. So before we even start talking about specifics, let's talk just for a second about, like Logan said, with features. We kind of got a little bit of it now. What do we want the person sitting down behind the computer to be able to do? Because if you think about it, if you're going to design something like Quake or Unreal, we can back up and simply say, all right, when little Johnny sits down behind his monitor and starts the game and he's playing, what's happening? He can move around, he can shoot, everything's being updated. So he's getting input as to a description of the environment, visually granted, but he's getting input.
So we know that so that's what commands can he do. That's what we're dealing with. What can he do to interact with this virtual world? So let's talk about our commands real quick and use that to help us determine all the features that are required to make the engine work, to facilitate what we want to do. Does that make sense?
Right. We're going to hammer out the input system for our engine then, if we're talking about inputs, things
Absolutely.
that we can do, because we're looking at is two different things, two different levels at which things happen. In the level, you're looking at the player, and you see the player moving to another room as something that can happen.
Mm-hmm.
And what we need to do is define what does the person type into their computer to cause that to happen.
Right.
Or in a shooter style game, the person, you talked about the person moving around. Well, what they would actually do would be to press the arrow keys or whatever input keys they had. So it's not like they are telepathically trying to move through them. It's like if they decide they want to move forward, they press the forward key. And then when they're done moving forward, they release the forward key.
Right.
What's that equivalent in our game? What has to happen? What does the player have to type into their keyboard to move into another room or to do all the other interactions?
So we know in planning, stage 1, we wanted to break this up into engine and level design. Phase 2, we discussed, all right, well, it's a grid-based type level that we're moving around in from just square room to square room to square room. Simple enough. Now, let's talk about our commands, and from our commands, then we can start deriving a little bit more of the feature set that's available inside this level we're moving around in. That's how I'm kind of thinking about it. And very much, if you think about this, this very much determined how our game came about. Because when we sat down and we started putting it together, at first we just wanted a system in which you could simply move. So let's go ahead and write that down. So move was one of the very first things that I told Logan I want to be able to do. I want to be able to move east, north, south, west, etc. And then I want us to relocate our position and get a new update, a new description of what the new room looks like. So let's go ahead and write commands right here, okay? All right, so moving. All right, well, if we move around, we also would like to be able to look. I mean, you do agree with me on that basically the way that Hyperion all came together in the end, the whole feature set was based off of us saying, all right, what can we do? Because originally Hyperion was a lot more advanced because you could scan, you could use, you could look at, and it really got involved.
Right, if you're looking at it that way, then we designed the engine around these commands.
Right.
Because we began just with a rough knowledge of how these games work. Well, what do? Well, you sit down, and if you want to move around, you type move. Let's just say that's how you want to move around. And then we decided, well, how do we accommodate something like move? Well, how is it limited? Well, you can move in 4 directions, up, north, south, east, west. How does that have to be represented? Well, that would be a grid. It would be a 2-dimensional grid, and that's how the room grid came about, is because of the way the move command worked.
Precisely. Okay, so now we know that we can look. Well, what else did we do? Well, we wanted some sort of interaction, right? So, pick up. So we can pick items up. Well, if you can pick an item up, that means you need to drop an item. But look at that. Just by saying pick up and drop, what did that just do? That introduced, back over here in the grand scheme of things, it just introduced items. Now we have items in the level. So that's a new whole type of object that we've got to deal with. Well, if you can pick items up, and you can drop items, at some point you're probably going to want to know, what the heck am I carrying right now? So we've got an inventory. So if I type in inventory, I get a list of what it is I'm carrying. And then there's one more that I just wanted in there because it was cute. Where the heck am I? And this just gave us, instead of getting a long description of the room, I didn't want a long description. I just wanted to say, like you guys saw at the very beginning of this video, you're in the main entrance hall. Good. I didn't want all the other details.
Right. Another way to look at this, and this may be stretching it for some people, but this was the difference between look and where am I, is on certain FTP servers, Unix systems, or file listings, you have 2 things you can do. You can list and see everything, or you can say print working directory and just say where am I without the stuff that's in here.
Precisely, and get exactly what it is you're looking for. All right, so where am I? And then as we were developing it, this is our base class of commands. Of course, it's very easy to add and remove commands. When we get done with the engine, you guys will see how. Even though it's done in an old school type of a method, it's still very easy to add these commands in or take commands out. We found that a couple more commands would be helpful for debugging because Zach ended up designing such a large game, and you start the game, and Logan and I didn't want to have to play all the way through the game just to test one possible ending, so we put in a few things to help us out. You call them debug commands. So we put in jump. And we also put in where is. Now, of course, where is expecting you to feed it like an item. No different than jump expecting a coordinate like 3, 6, telling you where to go, or move expecting something like north. All examples of data that needs to be sent with the command when you type it out. So jump allowed us to say, all right, I am right here, and I need to get up here. So this is going to be 0 by 0, where down here we're at 0, 0, 1, 2. So I could simply say jump to 0, 0, and I jump to right there. Very handy, because Logan could sit down at it, and the environmental suit in Hyperion Project is one of the things you need at one point. Logan would sit down and simply say, where is environmental suit? Enter, and it would respond with environmental suit is at 6, 8. Then Logan would say jump 6, 8. Boom, you're in a room with the environmental suit. Well, hallelujah. Pick up environmental suit. You put on the heavy environmental suit, and you guys see how it all goes. So these were more like debug commands for us.
And they became more and more useful as you got closer and closer to the end of the game, because when you first begin, testing out the first key is very easy with move command. It's right there, you walk over to it, pick it up, and use it, and say, alright, it works, we've tested this part of the game. Now, testing the final ending, which might depend on what you've picked up and where it is in the last rooms in the game. Every time you need to do that, you'd have to spend at least 10 minutes to play the game just to get to those rooms, only to find that there's a bug and it doesn't work yet.
Oh, yeah.
And then 10 minutes times how many times it takes to fix it. Whereas with the jump, you can just ignore all of the game except for the room you're interested in.
Exactly. So it ended up being a tremendous, tremendous help, especially when we started applying a whole bunch of rules. So I would say it's a pretty decent, rough overview, don't you? Text-based game. It's grid-based. These are the commands, the things we can do, basically just moving around, picking things up, dropping things. And from this, I want a game. I want to be able to turn this into a game. Fair enough?
Yeah, fair enough. This is the proof of concept, and it's not really, well, it's not a storyboard, it's an engine.
It's kind of an engine storyboard in a sense, yeah, which we're about to add a few more pages to.
That's a rough engine overview.
Yep. So with this in place, let's go down here and pull out yet another sheet of paper. So this paper, I'm going to come over here, and once again, I'm just going to flood this baby out and switch us back, grab up here, and we can go ahead and hide that away. So what do we want to talk about now? Well, if you guys recall all the way back into the little section in this video where we were talking about objects, we were talking about the remote control, TV1, TV2, and our DVD player, let's start talking about objects. So let's start generalizing everything, but let's try to do it at a very high level. Like, for instance, we know that our game, what's the obvious things? I'm drawing objects right now. This, just like I drew TV1.
Thinking about it, we're just getting closer and closer to a C# sense. And we talked about earlier that one of the requirements of working in C# is that you have to define everything as objects.
Right.
So we've then written out our idea for how the game works. How do we take these elements we've talked about and represent them with objects?
Yeah, and we're just going to do it with just basic common language for the most part. I mean, what are the obvious things? A level. We've got a level. So, all right, well, we'll probably, I'm going to say probably in case we change our mind while the development or the planning stage gets closer and closer to us coding. But so far, it would make sense for us to have a level. In the level, we're going to have a grid of rooms, basically. So we're going to need another object. It's going to be a room. We're going to need another object, because what can we find inside of rooms? Items. And we've got yet another one. And you know what? I'm going to put an S on these because we can have multiple rooms and multiple items. Does that sound good to you?
Right. And if you want to go or to some of the other things we mentioned was the static for one versus not static for having lots of something.
Precisely. So by putting the S on the end, it kind of denotes to me that there's multiple of those.
Right, and we'll end up denoting the type of object that has to be later.
Right. So here we got a player. All right. So that's all obvious stuff. I know I need those things. Now, all right, from a game designer point of view, and let's pretend we're not super game programmers yet. We need some sort of system within our code that's going to manage the game. I need the ability to start the game, to end the game. I've got to, well, check a series of game rules to make sure that, did I just die? Did I win? You know, what's going on? So what I'd like to do is I'd like to have an object in here that is a game manager. That's going to be his job. His job's to, let's get this party started. Let's do it. Let's check the rules. Let's just handle all the game stuff, game-related type stuff. So we have a game manager. All right, now what I'm kind of doing right here is I'm just going to put an O right here, and this stands for obvious. Everybody remembers obvious. So this is most obvious to least obvious. Make sense, Logan?
Right. Again, just thinking about the objects that exist, or I'm trying to think of a real-world example. You think of all the cars on a street as obvious objects that exist.
Well, let's just take a look at a car. What's an obvious? All right, you're going to build a car. All right, I'm not a car designer. Well, that's okay. Build one. All right, well, the obvious parts of a car are it has tires, it has an engine, it has a windshield. So we write out all the obvious parts. All right, what are some of the less obvious parts that you might not be thinking about? Well, it's got all this ducting inside that's going to handle pushing hot air and cold air through. And
right, it has just the fact that it even has an engine that lets you drive up hills as opposed to just downhills.
I consider it obvious. That's obvious. Everybody knows a car's got an engine.
Well, if you were building it.
Yeah, you're building it. Now, what's even less obvious than like your hoses and all? Well, now we start getting inside the engine and some of the parts that are inside the transmission or the engine. You know, these little rocker arms or this.
Right.
What are you talking about? No, that's got to be there.
Why does the transmission have synchros in it?
Yeah, exactly. So
what is a synchro in a transmission?
So the way we're designing this is we're starting from the most obvious and we're working our way down. Here's another one that is obvious in a sense, but you may not have been thinking about it. I need some way to process commands. So I need a command processor. Oh, and this is fantastic stuff here because everybody's like, oh, I'm new to programming and all this object-oriented stuff is kind of cool and all, but isn't the game manager going to handle processing commands? Ooh. Be real careful. You guys are getting into the world of object-oriented programming. I'll tell you what, Logan and I have spent many of nights over different programs arguing about what object something should be in or not in, or if these two objects should just be one object. An object needs to really be as tightly confined of a specific thing as possible.
Right, or to have one purpose.
Yeah,
to have one
to have
reason to
a
exist.
purpose. A game manager has a purpose, to manage the game. That's not processing commands.
Right, no, it doesn't. The game manager doesn't really care about commands.
Nope.
It cares about if you're in room 0 or if you're holding the apple.
Exactly.
Things like that. It's looking at the game data and deciding what does that mean. What happens when you have
the command processor, on the other hand, is going to process when you say move east or you say pick up axe or if you say help, it needs to process these commands. Those commands, while yes, it's part of the game, they're not related to what a game manager would be doing.
Even another way to look at it is we've been talking about defining objects, but things when you type in, that's just text.
Yeah.
Raw text. You can't obviously take that you've typed in something, or you could type in something that doesn't even exist. You could just type in the word cat.
Mm-hmm.
The game manager is not going to know what to do with that. It's not even an item in the game.
No.
You need a command processor to look at and say, is this a valid command? And if it is, what to do with it.
Exactly. So, but ooh, you were slick there because you brought text up. Well, in our game, the visual information we provide back to the player is just that. It's text. So we're going to be working with a lot of text. Well, what we're going to do is create an object. Again, we're working down here on a less obvious area. And this guy is going to be our text buffer. Ooh, our first big word of the night to someone who's not been working a lot with programming or ever with coding. What is our text buffer? It's a very generic term. It's a term we're throwing out there. We made it up. It's the name of our object. You could have called it monkey shoes. I don't know. Whatever. You get the idea. Text buffer is where we're going to deposit text. We're going to put text into the text buffer. You don't see it. No. That is in your memory in the computer.
That's what buffer implies, is that it goes into a holding container.
There you go. That's
for
what
later
it is.
use.
It is a holding container. Very good, Logan. So we have a text buffer. So this text buffer will allow us to dump text there. Well, we're going to find real quick, and this object that I'm drawing right here did not even get put on the spec sheet until late in the game. Is that right, Logan?
Yeah, very late in the game.
We're putting text utilities. We need to work with text. We're going to need to do things like word wrapping. We don't have to. We're going to do that at the very end of this because it actually gets a little bit complicated for a brand new programmer. But when the words were just getting chopped off as opposed to being wrapped around. So right in the middle of a word, like between, it would say bit, and then tween finishes on the next line. No hyphen, no nothing. And Terry playing the game back was just so frustrated with how it looked. So it's like, all right, well, we got to put word wrap in there. Well, we found that there was a few text utilities we needed. So it made sense to take text utilities. That didn't need to be in the text buffer. What's the text buffer's job do? It holds text. It doesn't need to be processing. Here we are in another situation where we're processing data.
And another reason it was put by itself in its own object is because we ended up needing text utilities. We needed word wrapping and other things that caused output. The game manager causes output sometimes separate from the text buffer. It causes its own text output.
Right.
But it needed access to text utilities, which would be if the word wrap was in text buffer, you'd get into a scenario where the game manager would say, work on my text instead of your text that's in the buffer.
Right.
And we wanted to keep that general. Instead of we don't even worry about text buffer if we're not using it. We just say, all right, text utilities, format this text for me. Or text buffer itself could use text utilities.
Precisely. So generalize things a bit, which was cool. And that's really it. Now we've got one extra one in here that Logan just threw in there for sheer coolness because it just had to go in there. This is not an object. Everything that you see right now, these are all going to be objects. We've got, and this is one of those things, remember I said you just got to have faith with us as we go through this very first Hello World application. We're going to put direction in there. All right, Logan, that's got to just blow some people's minds. Why direction? It's not an object, it's a struct. So it's a type of data that we're creating. Why direction, Logan?
It was, the reason I put direction in was to have the idea of north, south, east, and west kind of subseding the words north, south, east, and west. I wanted to define the idea of direction, as opposed to the raw text meaning a direction.
Okay.
Another more applicable reason was so that the actual text, north, south, east, and west, were not hard-coded throughout the game. It would make translating the game a lot easier if we could say that, you know what, north is actually represented by, or north, south, east, west are represented by up, down, left, right for some future version of the game. And we don't want to go and do a text replace for every instance of north and change it to up. Right. We want to have one place where we define the idea of north, south, east, and west, and that idea can be represented with a word of our choosing.
Okay, very good. So direction is one that some of you guys, as simple as we're trying to keep this, maybe a little wonky at first, but I think it'll really start to take shape once you see how it goes.
Even if you're not done with the idea of having an idea for a direction, it does have an upshot to doing it that way, and that is if you want to localize it and change what the text is, you have one place in code where you can change your direction.
Exactly,
text.
Which is very nice. Or add to if you want to start changing things that way. Okay, so now we've got a look at all the objects we want. Now, how about we take a look at program flow? How do we want all this to flow? Just in the most generic way possible. Let's go ahead and come up here and create yet another sheet. And again, I'll follow through with the same routines of grabbing our paint bucket, flooding it with white, flipping our colors back over to black, and grabbing a brush again. Let's go ahead and hide that away and continue. All right, program flow. Again, you don't have to be a programmer to understand this. I want it broke down in English. This is going to be the basic flowchart we're going to follow for making this whole thing work. We run the Hyperion Project the very first time. What do we need to see happen? Again, I'm not worried about low-level coding. High level.
Right, but we have talked about things that can happen. We talked about moving. We even talked about the game manager starting things or getting handed off to other things. We talked about text things happening. What actually happens if you were to run the game?
That's right. This is our flow now. Well, I know when I run the program, I want to see a title screen. we actually tried the game without a title screen, and it was great. Kerry played it for 1 hour and 8 minutes before he died the first time. He was about 20 minutes into the game, and I walked by and was like, "Oh, cool, you're still playing. How's it going?" He goes, "Oh, it's pretty cool. I'm definitely liking the feel and everything, but who am I?" I was like, "I don't know. Zach designed the level. I haven't played it. I haven't heard anything." He goes, "I don't know if I'm the janitor or if I'm one of the employees or if I'm a hired guy. I have no clue." It's like,
or if he's a hobo that just wandered into
wandered into the building. Exactly. So a title screen. All right, that's kind of important. Let's show a title screen. All right, after that's shown, and it's going to be one of those, press any level or any key type thing or something to continue on, what would be the next thing that we would want to have happen? Let me go ahead and put ourselves a little bit box here. Well, now we're going to stay very general, but a little more specific. I want to initialize my level. All right, very general terms. I want to create my level. Internally in memory, I want a level in place. I want rooms in that level. I want items inside rooms, and I want my player put into one of those rooms. The game's been initialized. It's ready to go.
Right, and the reason that this happens after the title screen is think of a lot of games you might have played that have levels you can load. You load the game, you see the title screen, and it's not until you hit begin that you see the level loading bar or screen appear.
Right.
Level loading and initialization doesn't happen until after the title screen.
Right. So, all right, so now here we are. Next thing, what are we going to do? Well, we have a level. It's initialized with rooms and objects and even a player. So it is time to go ahead and start the game. So we'll come in here and say start game. All right, pretty cool. Well, now the game has started. And one thing you guys are going to find out quite fast when designing games is once a game starts, you're going to be what is known, or inside what is known as the game loop. Because think about it. You're in a game like Unreal, you're running around, and all these things are happening around you. Well, code-wise, it's just basically going through a big loop. Did you just move? Well, let's move him. Did something else just happen? Did he shoot? All right, well, let's make the projectile go forward. And it just keeps doing this stuff over and over and over and over and over and over. And that's your game playing. Want to add anything to that?
Right. The loop can vary greatly in speed, how frequently it's run, depending on the type of game. Like in a modern, graphically intensive game, the game loop actually runs at something like 60 hertz, 60 frames a second.
Exactly.
In this case, we just have a text-based system where the loop only really runs once per command entered. So in comparison, very slowly, but it is nonetheless a loop. A command is entered, some things happen, you're left back at the command prompt, and this happens over and over and over again, and that is your game loop.
Of course, you could do a slight design change here and make it so that there was a true loop if you wanted to, where you could perhaps introduce enemies, and those enemies, as you're going through, you could simply say, did the player type a command? Okay, no, all right, well, you enemy, update what you're doing, you enemy, update what you're doing, and yeah, hey, did the player type in a command? All right, you, and just, it could
and
keep...
you would have turned the game from being turn-based into real time.
Precisely. Though it would still feel turn-based because you'd be like, enter room to north, and then all of a sudden there's a dragon in there and you die, but he wasn't there a second ago. So, in this particular case, as Logan says, it is turn-based. So what we need to do with that being the case is to simply come down here. Now we're designing the game loop. We need to, put a little box here, I can put some information in. We need to get user input. So get user input. So, we're waiting. User types in move north. Oh, thank you. I got some input, finally. So what are we going to do with that input? All right. To represent this, I'm going to give you guys the prettiest cloud you've ever seen because there's a lot of stuff going on here. We're going to need to process that input. So we're going to process your command. And after we process your command, but before we get back out into the room, we're going to apply our game rules. Huh? What are you talking about? Oh, simple. I came in here and I said move north. Well, what I just moved into was a giant vat of lava. Very next thing, apply game rules.
When in
if
lava,
idiot goes into lava, game over. Display this message. So now you can kind of see how it's just a big overall concept, a big idea right
The other reason it's drawn out as a cloud is that one could go so far as to draw a subtree within that cloud.
Oh, without a doubt.
But we're looking at this from the program standpoint, not the game. So we're just looking at how do these events happen as a program? What happens one event after another?
Precisely. All right, so process, game, rules. All right, so we've got all of this, or process command, apply game rules. So after we get back out of this, what are we going to do? Well, we need to basically come in here and say, is game over? So basically, did apply rules cause the game to be over? If the answer is no, what do you think we need to do? Well, get user input.
Ask for the next move.
That's right. Let's go ahead and say no. So I happen to move into a room that was just mildly hot, but it didn't kill me. Thank heavens. So we just come back up and we're waiting for the next thing. This right here defines, in a very general sense, our game loop. All right, fantastic. And finally, and I guess I can just kind of scroll down just a little bit for this, if answer is yes, well, that's it. We'll just say exit. Good enough. That's it. Boom, hop out, exit. It's over. Too bad. Good. Have a good time. That's it.
And really, this is all we're going to worry about at the program level.
That's flow.
Again, the complicated stuff in the process command cloud, that's all can happen in what is essentially its own little world. As a program, the only thing we care about after that's done is, should the game end now?
Right.
Has the user typed exit, or has he died?
Precisely.
If we should exit, we do. If not, we get another command and the game continues.
Yeah.
Because the loop continues.
So, I mean, it really, from my point of view, it makes great sense. We start the game, we show the title screen, we initialize our level, builds the level, puts all the rooms in place, put items in rooms, puts the player in the room. We start our game, yay, we're playing. Well, what do we do first? We put some input in, go north. We process the command, and we apply the rules, so we work on the commands we just did to determine if anything cool happened or if we died. And then we find out the result of that. Is it over, or do we loop back up and get more input and continue and stay stuck in this loop condition where it's just one of these? We just keep looping around until we finally exit out. Okay? So now that we have very basic program flow, a lot of this is all coming together again. You can't be sitting there right now thinking, all right, well, is the power station going to take crystals? That's not what we're doing. We're building the engine. The level designer, that's going to be his job. So everything we're doing here where we're putting the concepts together and slowly building up, he's got to do that too. He needs to start playing, all right, well, what's this world going to be like? What's going to interact with what, etc., etc. Okay, so with all that in place, let's bring this up. Is there something you want to add to that, Logan?
No, I was just going to recap on the idea that everything is kept simple. The game right now is boiled down to game over. No, right. And yes, continue game. So that's the only two things that can happen. The game can continue and the game can end.
Exactly. All right, we're going to ring in one more thing. And we'll do same thing one again, and we'll just drop this in here and flip it back. Now, this time around. Really, Logan, I just want to talk about just a few general overviews about how some of this stuff works. Just very general overviews, concept-based, just so that when we start putting it together, they can refer back to this piece and be like, oh, yeah, I remember that. So hopefully at this point you guys have been taking notes. The one big note that I want you to have is, and if you haven't, simply rewind and take the note. When I drew out all the objects, the level, the command process, draw that out. Draw that on a piece of paper. Keep it beside you.
Hit pause. Press print.
Okay, or do that. And now this, you can draw this one out too and add some notes based off what I'm saying here. Because I showed you guys a level as just an object. It's a box, a black box. And a player as a black box. And a room as a black box. But I don't want to go very deep into it, but I want to give just a very general idea of how some of this is going to work.
Well, we talked about where we drew a grid, and then we laid out a whole bunch of different things like rooms and items, and now we just need an idea of how these pieces fit together.
Right. So let's do that. Let's come in here first, and what I'm going to draw is going to be the level. So I'll just come over here. This is the level object. Now, objects can contain objects. Ooh, that's interesting. Think about it. My car is an object. When I get in my car, the object, is now containing another object, me, the human, right? So we can do the same thing right here. in our level, so let's actually name some of these things. We're going to say that this is our level. We are going to have a room grid. Okay, so a room grid, special kind of data that it's a special place.
It's a special way of arranging data.
Okay, yeah, I'm just saying it's a special way of holding data. That's a way I can live with for now. I'm trying to be very careful here because I want to stay super, super general. So let me come over here and let's get some sort of rich blue, and I'm going to draw this out. So here we go. This is a way inside my level of holding data. I know this may seem very confusing. Again, this is one of those places I ask you to have faith and follow along. This is going to be our room's grid. I've actually drawn this out for you guys once. Let's draw it again. Here's my room's grid. And let's say that this guy is divided up into a, I don't know, a 2 by 3 type grid. That works for me. We are dealing, ladies and gentlemen, with columns and rows. This is how we're going to access our rooms. This is going to become part of the heart of the engine. It's very important. Now, knowing your location, know your way around this grid becomes very important. Okay, this is going to be X. This is going to be Y. Right now, Logan, someone just put their head down and said, I told you there was going to be math involved. Just a little. All right, so that means that this right here, this area is what? Well, everything is 0 based. So if I was to put a 0 up here and a 1, and then on the side I was to put a 0, a 1, and a 2, this location, let's just put, let's call this Z. So Z would be equal to what? First comes column, 0, comma, and then next is going to be row, 0. So that's Z. Let's say that N is right here. What is N equal to? N is equal to, well, what column are we in? 1. What row are we in? 1. Okay? So let's say that K is right here. So where is K? Well, K is going to be in, well, what do we do first? Column, 0, 2. Simple enough, Logan?
You may even want to draw that out because let's say you want to figure out, let me grab the mouse for a second.
Absolutely.
Let's say you want to figure out where N is. If you had drawn this grid out ahead of time and planned out, okay, X is in this direction and Y is in this direction, well, where are we at N? Let's trace back to the X side. Oh, okay, that would be 1. Let's trace back to the Y side now. Oh, that would be 1.
Let me do that tracing for you because they may not have been able to say this. So what he just did is he said, let's trace back from here. Oh, we're there. Let's trace back from here. Oh, we're there.
So now we know, okay, if we want to place N in this cell, we need to place N at coordinates 1, 1.
Precisely. And same thing applies here. Where are we at with K? Well, I can trace it all the way back up and find a 0. And then so I found my column first. And then I trace it over here and I find my row, 0, 2. What do you know? 0, 2. Good idea. So there you guys go. So this grid is going to be important. But this grid is just a way of holding rooms. And rooms are our true objects, just like our car, our microwave. The room is an object. So this grid, so let's go ahead and draw it like a grid. Let's pretend, well actually it's not even pretending. The very first thing we'll make for Hyperion to test our engine is a very simple 2 by 2. Okay? So what does this grid contain? It can hold rooms. That's all it can hold. So inside of it is a room. Is a room. A room. And finally a room. So the red, as I've said 20 times, is a room. Alright? So now, if I was to query position 0, 2, I could get the specific room at 0, 2, because that would be the room that is sitting inside this location right now. Anything you want to add to that, Logan?
Right. The rooms, in this case, rooms grid, is a coordinate system. It is a method where we can find a place based on numbers.
That's right.
And it contains really nothing more than a room. The room's grid doesn't have a description. It doesn't have a lot of descriptions. It doesn't have any descriptions. It simply holds rooms. If you look at the room within the grid, that's how you find a description or some items. You have to use the grid to find a room.
Right.
The room then contains everything that a room normally would.
Exactly. So, now that we have rooms, we can get even more interesting. We now have to start dealing with items. So check this out. Here, we're going to look at a little bit closer is a room. And inside this room, what have I not picked on yet, is going to be a series of items. There's my telephone, there's a PDA, there's a lamp on the desk, and there's a chair in the corner. All items I can pick up and add to my inventory, though the chair's too heavy, so you can't pick it up. All right, so there we go. We have items. But it doesn't really look like that, because, come on, conceptually that kind of works, but I think I can clean it up conceptually to where it's even closer to what it looks like for real when we start dealing with it. In the room, we're going to be able to, we basically have a container for our objects, for our items, a list of items that are in that room. Let's represent that with a shelf. So as opposed to having all of these guys over here like this, you know what? Let's do it this way. Like, my colors will be slightly off, but that's just how it goes. I'm going to draw another room. Okay, like such. And I'm going to change my color again. And something about like that. And inside my room, I'm going to have a shelf. That is the only place objects can go. This is conceptual. Okay, it's not like you walked into the main entrance chamber and there's a shelf on the wall that happens to have. This is just an idea to help get across that I can only put my objects on this shelf. Okay, so my objects are on the shelf. Well, this shelf is a list. So down here to help you out, I'm going to put your crutch down there. Or shelf. So I can add things into my list. It's really kind of cool if you think about it, because let's say I just walked into room X. We're going to call that room X. And I want to know if room X happens to have the apple. What do I need to do? I simply need to look on the shelf and go through each item. First item, stapler, no. Second item, pen, no. Third item, apple, ooh, found the apple. That's what we're looking at here. Except when we start dealing with it in programming terms, it's called a list. So we're walking through the list. It's very simple. I'm looking for my apple. Do we have it? No, it's a stapler. Do we have it? No, it's a pen. Do we have it? Yes, it's an apple. Sweet, I can get the apple. Yay! Now, what's really cool, check this out. Let's make it even more interesting and more fun, since we're just really getting into all this. We have a player! And you can't have a party without a player. No player, no game. And guess what the player has? He's got a shelf too. He's got a list. Check this out. If I want to pick that apple up and move that apple over into my inventory, what am I going to do? Well, let's just come over here and change our color. That's what we're going to do. We're going to say, all right, this apple right here, let's add it to my list over here and remove it. Boy, that's the smallest eraser in the world. Oh, yeah. It thinks it's cute. Hang on. I'll just do it this way. Ha, you're funny. Da-da-da-da, da-da-da-da, and we remove it from right there. There. Empty shelf with smudge marks. But you guys get the idea. All right. So I have taken an object. You guys have actually just seen how the object system works. And this is a really good example of how Logan and I were discussing how this game was going to work on paper before we ever started coding. Logan's like, well, we can just use lists, and we can just populate the list with this particular type of object. Well, what kind of object is it? It's an item. Oh, it's an item object. Cool. So now I can walk into a room and say, check the room's list. Does it have any items in it? Yes, it does. Well, let's print those out. And you guys have seen that in Hyperion. Bring it back up real quick, Logan. So he's going to bring the game back up. And look at that. Move your mouse over where it says items in room. items in room. It's reading that list and printing out everything that's on the shelf, basically. Everything in that list is that one thing. Now type inventory. When Logan types inventory, except with an I.
That would help.
That just a little. Now when Logan types inventory, there's 2 things on his shelf, or his list. There's the 2 things. And so it just read those off to you. And so if we go ahead and jump back over here, basically what Logan just had was 2 items in the player's list, his inventory list, and it just echoed those out, so you had item 1 and item 2 when we've shown it out to the screen. Whew, there you go. That is an overview of what a level object looks like. Inside the level object, how it has a rooms grid, how the rooms grid contains in each cell a room object, how the room object, every room object, has its own list. And that list contains the objects that are in that room. And then a player can go into a room. So player, think about it. He's going to have property too, like position. Where the heck is he at? So, if I was to come over here and change this color back, one of the things he's carrying with him is something like, let's say, 1, 0, right? So what's the very first one? Very first one is columns. So he's going to be 1, 0. So we have a player that's standing up here. And how did we know that? Because one of the properties he has is a position. So we are able to quickly tell where he's at. But what's cool is I now know where the player is at. Well, let's check what I have in my inventory. Well, simple. Read his list. I have these 2 objects. Okay, fine. Let's drop one of the objects. Well, I know where I'm at, which means I know what room I'm in, so I know that I can take that object and put it into that room's shelf or that room's list. Ta-da! There's how all this works. So now we have the ability, let's pretend all of our commands are in place, to walk around. We know how the rooms work. We know how all that interacts back and forth. We know how we can pick objects up. We can store them in our inventory. We can drop them. The final thing, and this is going to be what in the end is going to be the only thing that I'm not a fan of from the whole thing, and neither is Logan, but it's very straightforward, and that is going to be our game rules. The game rules is going to be one of the most linear sections of code in this whole beast. It's going to be like old school programming. What do you mean by old school programming, Buzz? It's going to be just a bunch of ifs, right? Because we're going to keep this simple. Because right here we could really go crazy with a sophisticated game rule system. We really didn't want to do that. But we could simply say that if the player, here's a game rule example. If player is in 1, 0 and has dropped the apple in there, player's dead. Man, that apple hit the ground, and there was a chemical on the ground. It caused the apple to explode into apple shards, which immediately cut through the character. He's dead. Game over. So that could be a simple rule. Notice how I'm saying, if this condition exists, game over. And for the rules, we're just going to have a whole bunch of those. So Zach, as the level designer, came up with, I believe, 17 different rules at first, and he added a few more to it a little bit later in the day for the Hyperion Project. And the rules just said, if you're here and you're not wearing this, you're dead. If you're over here and you've put this there and you've put that there, this happens special. So that's pretty much how that works. So the only thing I guess I can add on top of all of this is we have inside of each room, you guys saw how we basically have a shelf with items on it. We also kind of have a list of directions too, of which way, or exits.
Right.
So which way you can go. So let's say this is just a final thought, so you guys have really seen it all. This room right here might have the list containing, what are my exits? Well, your exit in this case, sir, is north and to the west, or excuse me, to the east. Oh, fantastic. Well, logically that means in the room above, so that we can get back, we might want to do something like that. So what are the exits up here in 0, 0? Well, sir, it's to the south. We can just simply look at, well, what are our directions? What are our exits for that room? And we can, since it's like a list, it's a shelf, we can just keep adding directions to it, which means we could say, if you are over here and you just dropped the apple, this is a game rule, it could say, take this room and add a direction to it. Take this room, add a direction to it. And suddenly it's like a magical door just opened and you now have the ability to walk over to this room. And since we just added that direction, that room now continues to hold that exit, that new exit that we just gave it. So later on, if you wandered on down and over here, then you got tired and went back over here, that direction would still exist. Anything you want to add to that, Logan?
The only thing that would be nice, take the room you've got on the left with these individual items. Draw an exit on the north and east of that room.
This one up here?
Yeah, on the room with the lower one with everything scattered in it.
Lower. Oh, wait a minute. Were you down here?
To the left of that.
Oh, over here.
Yeah, draw a north. Actually, in the north and east, draw an exit.
North and off to the east.
And now throw a new list into the room on the right.
Okie dokie. I see what you're wanting. Yeah. And in that list, we have those two
north
exits.
And east.
And this would be north. Actually, let me do it that way. No, I can't. Not quickly, anyways. So this one right here would be north, and this one right here would be east.
But again, as far as the data is concerned, the direction or the exits north and east still reside in a list. We still go by direction and say, do we have north? No. Do we have north now? Yes, we do.
And so we can go that way.
Whereas the idea is that it's represented as though you have directions on the north and east side of the wall, but that's not actually where they exist.
Right.
In the game's data storage.
And they can see it. Pull Hyperion back up.
If we grab this.
Same thing in here. I'll go and do a look. Check it out. We already showed you that in the room we can list all the items in there, and we did. It says items in room, the Tri-D phone, possible directions. Now we're going to list all of the directions that are being stored in the directions list. East.
And the way that that's stored is the exact same thing as items. It is just another list.
Precisely.
The idea is that the game provides the illusion that these exits are on different sides of the room, but in reality, to us as a programmer, the directions just exist in another list. It's just another list that we can look through to look for exits, like we can look for items when we're interacting with them.
You got it. And which means through game rules, we can add and we can take them away, and that allows us the ability to make the game just a little bit more interesting, definitely more tricky, especially since this is such a simple game with very limited capabilities. So I think, Logan, that's pretty much everything. Let me go ahead and jump back over here real quick and bring up our layers, and we'll just walk back through to right here. Now what we're going to do is we're going to head over into Visual C# 2005 Express, and we're going to start our project up. It's going to be a very simple console app. We're not dealing with Windows and stuff like that. I want you guys to start getting a feel for coding. I know some of this will be sophisticated. Some of you guys are completely new to programming. Don't let that worry you. Don't let it scare you. I don't want it to. You, in your mind right now, tell yourself, I'm just doing monkey see, monkey do. Okay? Just follow along. C# is a case-sensitive language. Please be careful. If I make something lowercase, or Logan makes something lowercase or uppercase, it has to be the same. If Logan puts a symbol, such as a semicolon, at the end of a line, you must do the same too. Follow along. It's just critically important. Get all the way to the end, and then once you get to the end, you have a functioning game. You're going to be surprised at how much you picked up along the way, making this, in my opinion, one of the most exciting Hello World apps you have ever seen. So with that, let's go ahead and wrap this up, Logan, and we'll see you guys in the next lesson where we put the base skeletal framework together. Thanks a lot, guys.